So today's lesson is going to be solving 1- and 2-step equations. Don't forget the steps to solve equations. Always locate the variable first, decide what's being done to that variable, undo what is being done, and show that work on both sides of the equation, and then always solve for a positive variable, and be sure to check your work. You might get a negative answer, but your variable is positive. So for example, in the first one, you've got the variable x, it's being added by 7. You undo adding by 7 with subtracting by 7 on both sides. The 7's cancel out because they're inverses of one another, and x equals -3. You can always check your work by going back in and plugging in -3 in for the x plus 7. Does that equal 4? And in fact, it does, so you know your answer is correct. Second one, x subtract by 2 equals 3. You're going to add 2 to both sides. Those are inverses, they go away, and your value for x is just 5. Third example, -6 times x. You undo multiplication by division, divide both sides by -6, and x equals -8. On number 4, x divided by 4 equals 5. Undo division by multiplication. Multiply, sorry, not both sides by 5. Multiply both sides by 4. Because when you multiply something by 4, you divide it by 4. They cancel each other out. They are inverses. And what's going to happen here, you're going to get x equals 5 times 4, which is 20. On the next example, -2/7 x equals 4. Lots of ways to solve this one. You can set up a proportion. You can cross multiply and solve. You can multiply both sides by the reciprocal. In this case, I think I will multiply both sides by the reciprocal. So the reciprocal of -2/7 would be -7/2. You know that reciprocals multiply back to 1. So while these guys cancel each other out, you get x equals, don't forget, as a fraction, 4 is over 1. When you multiply the tops, you get -28. When you multiply across the bottom, you get 2. And x just becomes -14. On 9, you've got 9 take away 5x equals 24. You need to subtract 9 on both sides. You carry down -5x, and -5x is equal to 15. You divide both sides by 5. And x is equal to -3. Again, it's okay for answers to be negative numbers. You just don't want the variables to be negative. Number 7, you've got some like terms here on the left-hand side. Combine your like terms. So 4x minus 7x is -3x equal to -21. Divide both sides by -3, and x equals +7. When you get into the fraction problems, my suggestion is you always want to eliminate the fractions first. So I'm going to eliminate the fraction by multiplying by the only denominator that exists, and that denominator is a 2. So what I'm going to say to myself is, what's 2 divided by 2? The answer is 1. And 1 times the numerator x is just plain old x. So essentially, these 2's have canceled each other out. That was the only denominator, so I can't forget to distribute the 2 through the rest of the problem. Then I've got what is 2 times 5, or plus 10, and what is 2 times 11, or 22. Now I have a nice equation with no fractions. Subtract 10 on both sides, and x is going to be equal to 12. Good check for that. Taking 12 divided by 2, which is 6, added by 5, that's 11, and all is good. Next one, another fraction in the problem. Again, the only denominator that exists right here is a 6, so I want to get rid of that denominator by multiplying the entire equation through by a 6. So that means that 6 times 7 is 42 equals, when I multiply the 6 and through by this fraction, essentially what I'm doing is taking my blue 6, dividing it by denominator, which is also a 6. 6 divided by 6 is 1. 1 times my numerator 5 is 5 times the x is 5x. So I'm left with 5x over here because remember 6 divided by 6 is 1 times 5x is 5x. And I can't forget it's also 6 times 8, which becomes minus a 48. Then what I'm going to do is add 48 to both sides. And you're going to end up here with saying 90 is equal to 5x. You divide both sides by 5, and 18 is equal to x. Last problem. They all have fractions in them. So what I need to do is find some number that's going to eliminate the 3, the 2, and the 6 all at once. And that's going to be the common denominator, which is 6. So I'm going to multiply the entire fraction through by a 6 again. The idea is that you take whatever that common denominator is, you divide it by the denominator of the problem, and then multiply it by the numerator. For example, 6 divided by 3 is 2. 2 times 2x is 4x. That was this guy. This guy, minus to minus. I can bring that down right away. 6 divided by 2 is 3. 3 times 1 is 3. When I multiply the 6 in by this fraction, 6 divided by 6 is 1. 1 times 5 is 5. There are no more fractions. Life is good. Add 3 to both sides. 4x is equal to 8. Divide both sides by 4, and x is equal to 2. Okay? If you are used to solving problems with fractions by adding and subtracting fractions as they are, getting common denominators, etc., that is fine. I prefer to eliminate the fractions by multiplying through by a common denominator to have my equations look a little bit nicer. But again, it's up to you. All right? Good luck with the homework.